Hello students, welcome back to my channel. So today I will be talking about one problem which is not a very usual problem because there is a slight difference in this particular problem from the topic LPP. And even though we know there is less weightage given to LPP, but we can very well score the solid marks in this. So let's directly jump into the problem. So the problem is presented here. It's determine graphically the minimum value. So what we are supposed to find here, we are supposed to find the minimum value. So we are supposed to find the minimum value of the objective function this. So this is my objective function. Usually they denoted by z, and as of now in 12th we don't have the word problems in the syllabus, so we just are left with the function which is given in the question itself and the constraint. Constraint in simple language I would say conditions. So whatever value you put here x and y, it should satisfy all this as well. Okay, now let's jump into it. Now what are we supposed to do initially is we just have to plot all the equations given in the constraint, right? Now the first thing is x is greater than equal to 0 and y is also greater than equal to 0. So this tells me that it is in first quadrant. So you don't have to worry and just extend the line to all the quadrants. Now let us start plotting. Now when you plot, you don't get confused with the sign. Just consider this equation, not the inequality. Equation, just take the equal to sign. Now you know how to get the value of x and y. What you simply do is you put x as 0, get the value of y. Next you put y as 0 and get the value of x. This is the common thing that we ask students to do because this is easy compared to substituting x as some number and y as some number, because most of the time you won't get a whole number, and placing, like in this condition, placing a rational number or decimal number is a little bit slightly I would say difficult. So we prefer to tell them to put 0 0 x and y and get the value. Now here is another equation. So the point through which this equation passes through, or this line passes through, are these 2 points. And the third one, again we placed x as 0, got the value of y. Placed y as 0, get the value of x. So here we need to make a slight difference. It's not an inequality. Here we are just doing for equal to. That's an equation. Now what's happening is, this inequality, that means this greater than or less than sign, is used to tell us the region. Because see, a line always divides the plane into two parts, right? This part and this part. But how do I know from which part I am supposed to take this solution is actually given by this greater than or less than sign. Now let's see the graph, how I have plotted. So this is the graph. So whenever you plot the graph, of course you need to draw x and y. And then the important thing is, I would suggest you to please mark also. And then scaling also you should write. Okay, scaling is like x-axis. So we could write just 1 centimeter is equal to 1 unit. Similarly for y-axis, 1 centimeter is equal to 1 unit. So I would suggest that you write scaling as well, because that's important. Now let's coming back. So here is the line that I plotted. Simply you just, whenever you divide, like you don't worry about I should divide in a multiple of 5 or multiple of 2. You just take it, just see the points that you got. Now you can see all the numbers are just less than 6. 6 is the max I would say, right? So I think 1 2 3 would work. Now if it's going very high, because sometimes we get like 500x plus 20y less than equal to 30. So that time x and y would go bit high. Now depending on that, you have learned scaling, you can take the multiple as something, maybe multiple of 2 or 3 or 4 or 5, depending on the values that you got as in point through which the line passes through. So I have plotted 1, 2 and 3, all the 3 constraint lines here, as you can see. Now how do you know which region I am supposed to take the solution from? So for that, what you are supposed to do is, let's consider, I will do for one line, the same goes for all. Let's consider this line. Okay, now in this line, what was the actual constraint? It was less than equal to 12, right? So it was 2x minus 3y less than or equal to 12 was the actual constraint. The best thing you could do is you just simply go and put 0 comma 0. That means point 0 comma 0. Now you can see this line is divided, has divided the whole plane into two parts. In one part, your 0 comma 0 is line. Now if the upper half is the solution, or you can say the region, then 0 comma 0 should satisfy this. So let us check. So when you put, it will be 2 into 0 minus 3 into 0, which is nothing but 0, and 0 is less than equal to 12. That's correct, and that's the reason I am taking the upper half as my solution. You can see I took the upper half. I took the whole, but while placing I didn't do that because this region is not included, because my last constraint was this. So everything been first region, and that's why you can see this also will be included for this line. But then when you come to this line, this part is the common thing. So when you combine this line and this part is not common to both, and that's why we have just removed it. We just consider the common to all the three. Same thing you do with this line. You will see the upper half is the feasible region. When you do for this, you will see the lower half. So when you combine all the three along with the fourth constraint, you will see this is the only region you will get. Now the most important thing here is this region is unbounded. You can see very well. This region is unbounded region, right? That we can observe. So sometimes you will get a bounded, sometimes you may get an unbounded region. Now let's go. So what we actually do to get minimum? We will just take the critical points, that means the boundary points we just take and substitute it in the function, subjective function, and get the value. Now we were talking about the minimum, so we could see that minus 300 is the minimum. So minus 3 is the minimum, but what students do is, it comes as a 5 marks question most of the time. What students do is they will just stop here. They got the value and that's all. That's the answer. But that's not the answer. The important thing here is the region is unbounded. So I need to check whether this is actually the solution or not. For that, what I will do is, this function is giving me the minimum, correct? So this equation is true. X and y value is 6 and 0. Okay. Now what I am going to do is, I am going to place this inequality on the graph. That means what? I am trying to find whether there is any other x or y for which this subjective function is less than minus 300. That means, is there any number for which I will get subjective function less than minus 300? Because as of now, this is my minimum, smallest value. But if I get any other x and y for which the subjective function is lesser than minus 300, then that's a problem. So I have plotted over here with the blue line. Now you can see this inequality when I place, this is the region that I got. Now what can you say about this? That means I cannot say for which point I will get less value. I have many points for which this subjective function will be less than minus 300. Right? That means minimum does not exist. We don't have any minimum. It's unbounded region. See, this also keeps on going, this also keeps on going. You will have infinite points for which you will get the subjective function less than minus 300, and we don't know for what value of exactly x and y you will get this less than 300. Right? We need to get a unique solution, or at least let's say 1 or 2. I need to get the points. I cannot say the points because there are infinite points for which you will get less. So here the answer is no minimum value. Okay, so I would again say, whenever you get the minimum value or the maximum value, so as in contradiction, you go and find the reason I am putting less than is I am doing minimum. If it was maximum, I would have put this to check whether there is any x or y, so that the subjective function is greater than the value that I got. If you get any region which is in the feasible region, then the maxima or minima will not exist. I hope you understood this question, and this question has already come in boards earlier. So All the best for your exams. I will be uploading more videos, and the next video will be coming up on probability. I hope you like the session and understood. Take care, and please like, share, and subscribe.